Hey there, welcome to Math 316 Real Analysis at Humboldt State University. I'm Dr. Tyler Evans, Professor of Mathematics in the Humboldt State University Math Department. I'm excited to work with you guys in this first semester course of Real Analysis. The purpose of this short video is just to kind of go over the highlights of the course syllabus. If you haven't already done so, I'd recommend you check out the short video I made on the structure of the Canvas course. We're looking at the main page of it here. I'm going to go ahead and click on the syllabus link, take us over to the course syllabus. Topmost section is kind of course registration and contact information. There's my email address right there at the top. It's the best way to get a hold of me. I check my email frequently. I'm not physically on the HSU campus, so the phone number there is not a very good way to get a hold of me this semester, but the email is. Canvas messaging is also okay, although I tend to check email a little bit more frequently. Our course is going to meet 4 days a week at 3 o'clock, and I'm going to have office hours in the hour and 15-minute period leading up to those. So that's 5 office hours a week. And if you need to talk to me at other times, please feel free to contact me and we can make some additional arrangements. Okay, next section is the course description. What is a course in real analysis? Well, it's really kind of a rigorous look at the topics that you saw in calculus. A lot of calculus courses, ours included here at HSU, don't include a lot of proofs because, well, the foundational kind of rigorous development of the real number system is missing. And the people in calculus really don't have the background to do a lot of these proofs. But you guys, having completed Math 240, the primary prerequisite for the course, have a little bit of experience with proofs, and we'll develop the material that we need about real numbers, in particular bounded sets of real numbers, so that we can rigorously develop things like sequences, limits of sequences, functions, limits, continuity, differentiation, and integration of functions of a real variable. All right, with respect to our course textbook, which is linked to from the front page, we're going to cover most of, but not all of, chapters 1, 2, 4, 5, 7, and 8. Okay, here's the textbook information itself. We're going to use Thompson, Bruckner, and Bruckner, Classical Real Analysis, and that text is available at no cost to you. So you can just download it as a PDF. Right? In terms of device requirement, well, we're meeting virtually, so you're going to need to come to class on Zoom. Zoom minimally means that you need a computer with a reliable internet connection, a camera, and a microphone. Right, so that's kind of the absolute minimum requirements to participate in the course. You're also going to be submitting your work to me for grading. You have to do that digitized somehow. I'm going to insist that you submit multiple page single file PDF exams. So there's some information on the technical tools page if you need some help converting your written work into a digital format. You can also reach out to me. I'd be happy to try to help you. In terms of recommended devices, I know it's not possible for everybody to have one of these, but if you do have a tablet or an iPad that you can use with a stylus, it really facilitates the electronic document exchange. So I use an iPad to create my lecture notes and so on. So I would recommend that you get one of those if possible, but I understand that they're not free and it might not be possible for you to have that. But okay, in terms of calculator and software, not really relevant in this course. It's going to be kind of a theoretical math course in which I want to show you how to develop carefully and prove some of the ideas that you learn in calculus. I'll occasionally maybe use some Desmos Mathematica to illustrate things graphically. I'm definitely a believer that people learn mathematics by playing around. So when we study sequences and whatever, you can even use spreadsheets and so on to kind of play with examples. There's some information on the technical tools page there. Okay, how am I going to grade you? What kind of assessments will I make and how will I calculate your grade? Primarily, it's homework assignments. The graded course components consist of assignments, these things that I'm calling reflections and exams. So there'll be a homework assignment every week. I'm going to scale it down to just 5 problems. You're going to submit 5 problems to me, but I'm going to try to encourage you to think about more than that. You can certainly talk to each other and talk to me about other problems, but in terms of being able to manage the grading load, I'm going to have you submit 5 problems a week to me. We're going to look at this in class on Tuesday, so I won't open the files now, but I wrote 2 documents. One's called the Guideline for Submitting Homework. So it's kind of my expectations about what it is that you're going to do to prepare written homework. It's different than, say, in a calculus course where your homework just consists of kind of disjointed calculations that aren't annotated. So these guidelines will, among other things, talk about, writing things in complete sentences, using correct notation in the correct conventional way, and so on. And then I've also created what's called a grading rubric. So it's sort of the criteria that I'm going to use when I assign scores. So you definitely want to familiarize yourself with both of these documents, because without familiarizing yourself with them, your homework scores are probably going to be lower than what you'd like. Yeah, so I'm going to follow this rubric and these guidelines. So even if you quote unquote have done the math right, you could get low homework scores because you're not writing it up according to the guidelines. You're not using the correct conventions. You're not using notation correctly, and so on. So we'll talk about that more on Tuesday the 19th when we meet. Okay, you can see by the graded components, I'm going to skip down here. Homework is absolutely the most important part of the course. You learn mathematics by doing it and talking to other people about it. It's very much a social subject. So I hope you guys will organize a Discord server, text chat, use the discussion forum on Canvas, but talk to each other about the material that we're learning. Math is absolutely no fun in a vacuum, and chances are if you're trying to do this all by yourself, you won't learn it very well. One more thing I want to say is that I'm assuming that you are familiar with the university policy on academic honesty. I take it very seriously, and in particular, everything that you turn into me needs to be your work. So you can talk to each other about homework problems and how to prove stuff. You should. But when you're turning something in, it should be something that you produce in your own words. And in particular, you shouldn't be copying somebody else in the course's work. You certainly shouldn't be searching for things on the internet and copying them. Anything that I suspect is not yours, how I'm going to handle it is I'm going to ask you to meet with me one-on-one with Zoom and just talk to you about it. And if you can't convince me that the work you're submitting is yours, then I'm going to give you zeros on those assignments. And moreover, I'll probably give you a failing grade in the course for academic dishonesty. So I take it very seriously. You can check out this course policy on plagiarism if you want some more details, but hopefully it's not an issue. I know with the internet these days, it's very tempting just to search stuff out, and you can search stuff out, but if you find yourself submitting work that you don't really understand, that it isn't coming from you, then you're not being honest, and that's not okay. That's against the university policy. All right, so that's homework assignments. Each week, there's also a sort of small, just type it into a text box assignment that I'm calling reflections. And it's basically a chance for you to kind of look back on what we did that week and talk about it in your own terms. All right, so those will be done once a week. They're always going to be due, same as homework, due on Sundays at 11:59 p.m. Okay, we're going to have two exams, a midterm and a final. The dates are March 19th and May 14th. Those exams will become available on Canvas at 8 o'clock in the morning and be due by 11:59 that night, submitted as a PDF. Same thing with academic honesty. I'm just going to use the honor system and assume that the work you submit is your own. Okay, homework, 60% of your grade, reflections are 10, the midterm and the final are 15 each. So that's the 100% of the course grades. I'll use a standard distribution in assigning your letter grade. So just sort of break it down like that. Your grade will always be current on Canvas. You'll know where you stand. And the rest of this I'm going to leave to you. There's some important dates, adding, dropping, changing grade modes and whatever. Double check those if you're going to use any of them. I've done my best to accurately record them here, but it wouldn't hurt double checking them with the university. Got the course learning outcomes. I'll let you check it out. They're the specific outcomes for the course, how they fit into your math degree and how they fit into your university degree. And then down at the bottom here, I hope some useful links to resources. Maybe you need some accommodations. Maybe you need to familiarize yourself with the add drop policy. I already mentioned the academic honesty policy, disruptive behavior, and so on. So those are there just as sort of resources for you. And the bottom of the syllabus is just kind of the summary of the course. It'll just show you the assignments as they become available to you. These due dates will have dates on them as I generate the assignments as we go through the course. All right, so that's a real quick look at our course syllabus and the details of the course, and I'm looking forward to meeting you guys on Tuesday. Thanks.